Hey there, math explorers! Welcome back to our cozy chalkboard corner. In our previous lesson, we introduced variables and constants, those unknown or changeable values and those numbers that never change. We even got a sneak peek at how these elements come together to form algebraic expressions. Today, we're stepping it up a notch. We'll learn about the building blocks inside these expressions, what we call terms, how to identify coefficients, and even how to combine like or similar terms to simplify our expressions. But don't worry, we'll keep it slow and simple, with plenty of fun examples. Let's dive in. Just to be clear, an algebraic expression is any combination of variables and constants put together with mathematical operations like addition, subtraction, multiplication, or division. For example, 3x plus 5, 2y squared minus 7, x divided by 2 plus 6. We already covered that in our previous video, but now we'll zoom in to see exactly what's happening inside these expressions. First, let's talk about terms. A term is a single piece of an algebraic expression. It can be a single constant, like 5 or -3, a single variable multiplied by a coefficient, like 2x or 4y squared, or even a product of variables, like xy. For instance, in the expression 2x plus 3, y minus 5, we have three terms, 2x, 3y, and -5. Let's zoom in further on a term like 5x. The number in front of the variable, which is 5, is called the coefficient. It tells us how many of that variable we have. Think of it like a price tag for the variable. In -7x, the coefficient is -7. If you see just x with no number in front, you can imagine the coefficient is actually 1, because x is the same as 1x. Next up are like terms. Two or more terms are called like terms if they have the same variable raised to the same power. This means 3x and 7x are like terms because they exactly have x as the identical variable. 2y squared and 5y squared are like terms because they both have y squared. No more, no less. 6 and -2 are also like terms, but only if we're looking at constants. Essentially, constants are considered like terms with each other because they don't have a variable. When you combine like terms, you're basically adding or subtracting the coefficients of terms that share the same variable part. Here's a simple example. 3x plus 5x. As you can see, both terms have the same variable, x. To combine them, we will add the coefficients, 3 and 5, which is equal to 8. Therefore, our combined term results to 8x. That's how we simplify expressions by grouping or combining like terms together. Now let's check out a few examples that illustrate terms, coefficients, like terms, and combining them. Identify the terms. 2x and 7x. Both share the same variable x, so they're like terms. The coefficients are 2 and 7. To combine, add the coefficients 2 plus 7 to get 9, so it simplifies to 9x. Let's try a more complex four-term expression, 3y squared plus 5 plus 7, y squared minus 2. First, let's group the similar terms. 3y squared and 7y squared have identical variables, which is y squared. On the other hand, 5 and -2 are both constants, so we can group them together. Now, our goal is to combine them separately. For the y squared terms, we will add the coefficients 3 and 7, which is equal to 10. For the constants, we will be adding 5 and -2, which is equal to 3. This will result to a simplified algebraic expression 10y squared plus 3. In our upcoming videos, we will talk more and provide more examples to make it easier for you to solve problems like this. So don't worry, we got you covered. To wrap it up, why do we care about identifying terms, coefficients, and like terms? Well, being able to combine like terms and simplify expressions is a core skill in algebra. Whether you're solving equations, studying engineering, or just trying to balance your donut budget, simplifying expressions makes your life easier. When you reduce an expression to its simplest form, you cut down on confusion and set yourself up for solving bigger, more exciting math puzzles. Thanks for joining me on another math adventure. If you have questions or if something in today's lesson tickled your curiosity, drop a comment. In our next video, we'll explore evaluating these expressions for specific variable values and maybe even solve some basic equations. Until then, keep exploring, keep practicing, and remember, math is a journey, one step at a time. See you soon.